In this video, we're going to do a brief review of the metric system and how it is set up. Let's start with the standard unit of a meter, the base unit of a meter. Okay, a meter is roughly like a yard. So if you can kind of picture a yardstick. They're pretty close, though the meter is a little bit longer. Okay? The meter is that standard unit. Now sometimes we have the need to measure greater lengths or greater distances. So the meter itself might be too cumbersome. We might end up with too many meters. So the first thing we can do is group 10 of those meters together. And end to end, that length that is created, those 10 meters are what we call a decameter. We abbreviate that as DA. Now a decameter, being 10 meters, is a good larger unit. But sometimes we might need an even larger unit. Let's say we wanted to measure the distance between building D on campus and building S on campus. To measure it in meters or decameters, we might end up with a lot, so we can create a larger unit. The next larger unit is created by taking 10 decameters. So think of it as 10 groups of 10 meters. That's a total of 100 meters end to end. And that length is what we would call a hectometer. Hecto meaning 100, and that's abbreviated H. We may have the need for an even larger unit. Again, what if we wanted to measure the distance between, say, Chicago and Paris? Well, the next larger unit comes from taking 10 groups of 10 groups of the hectometers, so 10 groups of 100 meters, which 10 groups of 100 is 1,000, or what we call a kilometer. We can continue this on. We could take 10 groups of the kilometers, in other words, 10 groups of 1,000, and we'd have 10,000 meters to create another larger unit. So this pattern can continue of grouping by tens. However, going back to that base unit of a meter, we may want to measure something smaller. The meter may not be as accurate if we're measuring something smaller, such as the length of your foot, the length of a finger, the width of a penny. So the first smaller unit is created by taking that meter stick and cutting it into 10 equal parts. Each of those parts is 1/10 of the meter, and it's what we would refer to as a decimeter. You'll notice deci and deca both start with D, so deca is given 2 letters, while deci just gets the D. All right, a decimeter, which is 1/10 of the meter, is a good smaller unit, but we may need to measure and be more accurate, measuring smaller things. So again, if we're measuring the length of your foot, measuring in decimeters might not be the most accurate thing. So what we can do is take that decimeter and cut it up into 10 equal parts. So now we've taken our meter, cut it into 10 parts, and taken those and cut those into 10 equal parts. So we now have 10 parts of the 10, in other words, 100 equal parts in our meter, which is what we call a centimeter. Getting an even smaller unit comes from taking the centimeters and cutting them up 10 times. So we've taken 100 little parts and cut them up 10 times. That means we have 1,000 equal parts in our whole, and each one of those little parts is called a millimeter. The millimeter is 1/1000th of the meter. We can continue this on. We could take each millimeter and cut it up 10 times, thus giving us 10,000 equal parts in our whole. And we could keep going and going if we had the need to create smaller and smaller units of measurement. So that's the really nice thing about the metric system. One nice thing is that we can get larger or smaller units sort of at will, just by breaking things down into 10 parts or grouping over and over by 10. Another nice aspect of the metric system is regardless of your base unit, whether you're working in meters, liters, or grams, they are broken up or grouped in the same fashion. In other words, let's say that we had a liter. Okay, that's like maybe a larger water bottle. If we took 1,000 of those together, that amount of liquid is what we would call a kiloliter. We could take that bottle and cut it up into 100 equal parts, and one of those parts is what we would call a centiliter. The gram works the same way as the meter and the liter. Maybe you remember from a science class the balance scales and those little gram weights. If you took 10 of those gram weights together, That mass, that weight, would be called a decagram. If you took that little gram weight and you cut it up into 10 equal parts, each one of those equal parts is what we would call a decigram. So the metric system is very consistent regardless of your base unit, whether it's the meter, liter, or gram. We create larger units by grouping by tens over and over again, or by breaking it down into tenths, and each of those smaller parts into tenths again. What we're going to talk about now is converting within the metric system, which is actually a pretty easy process. We'll do some examples of converting within the metric system, and then we'll talk about why it works. That will be in the next video. But before we do that, let me just show you one other cool thing about the metric system. If we treat our base unit, the meter, liter, or gram, as our one whole, that's our starting. The decagram is 10 of whatever the base unit is. The hecto is 100 of whatever the base unit is, and the kilo is 1,000 of the base unit. Deci is a tenth of the base unit, centi is 1/100th, and milli is 1/1000th. If you look at these numbers, think about our place value system. If this is the ones place, just to the left of it, tens, hundreds, thousands. Think about going to the right of the ones place. The first place value to the right of the decimal is the tenths, then the hundredths, then the thousandths. So the decimal, or the metric system, is based exactly on our decimal number place value system, which makes it so easy to work in. In the next video, we'll look at converting within the metric system.